Hello everyone. In this lecture, I will be talking about Legendre Equation, solution of Legendre Equation, and then we will discuss Legendre Polynomial. In this lecture, and I will make two lectures out of this. And the next lecture we will give some properties of our identity satisfied as Lagrange's polynomial. So, not Lagrange, Legendre Equation. See, the Legendre equation has the following form. 1 minus x square y double dash minus 2x y dash plus alpha into alpha plus 1 y equal to 0. Here alpha is a real number. So later on, when we will talk about polynomial, then this alpha will be a natural number or non-zero, non-negative integers. So see, this equation can also be written as 1 minus x square into y dash whole of dash, because if we take this 1 minus x square into y dash whole over dash, then if we take the derivative, this will come. So instead of this, we can divide by this term 1 by x square. So it will be y double dash minus 2x by 1 minus x square plus alpha into alpha plus 1 by 1 minus x square. So this will be of this from this. So see, px is this and qx is this. And these are analytic at 0. Only problem is plus minus 1 point. Otherwise, this is non-zero. So these functions p and q are analytic at x equal to 0. So we know one theorem that if the equation of this form where p and qx are analytic, then we can get a unique solution which is also analytic. Analytic means basically it has a Taylor series expansion. So since these are analytic function, actually this is analytic function in mod of R less than 1. If mod of x less than 1, then that is analytic. So we will get a solution, analytic solution, which is unique. So analytic solution, so we take y equal to cn into x to the n, where n equal to 0 to infinity. So what we will do, since this is this, we will take derivative and second derivative. First derivative will be n cn x to the n minus 1. See, here n equal to 1 to infinity, because the series is what? C0 plus c1x plus c2x square dot dot dot. If we take derivative, the constant term will not be there. So it will start from c1. So that's why here n equal to 1. Again, if we take derivative, it will be n into n minus 1, cn x to the n minus 2. So here one more constant will remove, then it will start from 2 to infinity. But the thing is that we can start from 0 also, because if n equal to 0, then here since it is multiplied by n, so that will become 0. Here also we can start from 0 to infinity, because when n equal to 0, then it's also 0. When n equal to 1, then also this term is 0. So as a sum, it does not matter. But we can, if we take the derivative, so that will be the, it will be from n to n equal to 2 to infinity. Okay. Now, if we will put those values, see, here n is from n 2 to infinity. If and this x to the power n minus 2, if we want to make this power n minus 2, that is, we assume that n minus 2 equal to some m. So n minus 2 equal to m. So n equal to what? 2 plus m. 2 plus m. And since n is from 2 to infinity, the m goes from 0 to infinity. So instead of writing this, we can similarly write n equal to 0 to infinity. We can put n plus 2 instead of n. So that is also valid. So we put n equal to n plus 2. So here also n plus 2 equal to 2 to infinity, n plus 2, n plus 2 minus 1, cn plus 2 x to the power n plus 2 minus 2. So this will become this one. Here we have written n plus 2 into n plus 1 cn plus 2 x to the power n. So that I will come again later. So first we will put this 1 minus x square into this minus 2x into the first term and then alpha into this term. We have put all the value of y dash and y dash. So we have multiplied this. So 1 with this is this one minus x square. It goes inside and it becomes x to the power n. This also x we have taken inside, so it is 2n cn x to the power n, and we have this one. What I was saying, so this is because we want everywhere the series is from 0 to infinity, and not only that, we want x to the power n everywhere. So see here x to the power n is there, x to the power n is there. Only this is not form of the form x to the power n. So as I earlier mentioned, this also, like, we can make it 0 to infinity. There is no harm because we are adding 2 zeros. But we also want this also x to the power n. So that's why we put n equal to, because this is an identity, you can say. So we can put n equal to n plus 2. So if we put n plus 2 equal to 2, so 2 gets cancelled, n equal to 0 to infinity, it is n plus 2 into n plus 1 cn plus 2 x to the power n. Now all the terms, the summation is for all the things, it is n equal to 0 to infinity. Here also see, here was n equal to 2 to infinity, but since if we put n equal to 0, the whole thing will become 0, and if in 1, then also it will become 0. So that's why we have written it n equal to 0 to infinity. And x to the n is here, so we don't have to do anything. So if we take common all the things, summation is over 0 to infinity. This term will be this is from coming from this is from this. So this is true for all x to the n. So if we compare the like power from both the sides, what we will get? We will get this whole the bracket is 0. So n plus 2 into n plus 1. So we will take the other thing and see. On the other terms, they are only cn. So we have separated cn plus 2. We have written it in terms of cn. Say if we multiply this, this will become this, and if we factorize this, it will be alpha minus n, alpha plus n plus 1. So cn plus 1 will be what? Cn plus 1 is equal to minus by this into cn n equal to 0. So we can write cn plus 2 in terms of cn. So if we put 0, 1, 2, 1, 3, dot, 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 we will get, first if we put 0, so it will, we will get C2. C2 will be what? Alpha plus 1 into alpha by 1 into 2 into C0. And C3 will be what? If we put 1 here, so it will be C3. So alpha plus 2 into alpha minus 1 by 1 into 2 into 3 into 1. If we put 2, we will get alpha plus 3 into alpha minus 2 by 1 into 3 into 4 into C2 will come. Again, if we put the value of C2, it will come like this. Alpha 1, alpha into alpha 1 into C2. And C5 will be this. So all the even terms are coming in terms of C0. And all the odd terms are coming in terms of C1, multiplied by C1. So this has similarity, like see, here we are starting with alpha into alpha plus 1, and then we are, for this term, we subtract the odd terms, and here we are adding. Next term is alpha plus 3 and alpha minus 2. Then next term will be alpha plus 5 and alpha minus 4. And this is See, this is 2 and this is factorial 2. This is 3, so it is factorial 3. This is 4, this is factorial 4. This is 5, this is... So for the odd, there is one series, and for the even terms, there is another series. So by induction, we can say for the even things, what it is coming. For this C, the even terms are multiplied by C naught, so there is C naught. And what we have to start? Alpha plus 1 into alpha in the middle, and in this side, we will subtract the even numbers from alpha, and we will add the even number in the right side, and then minus 1 to the power m, because see, this is minus and this is plus. Again, the C6 will be minus and C8 will be plus. So C2m means the odd number of C2m will be this, and the even number will be minus 1 to the power m. See, here we are starting alpha minus 1 and alpha plus 2, and again we subtract the even numbers. The next number will be alpha minus 3, then alpha minus 5, alpha minus 7. And here we will add alpha plus 4, alpha plus 6. So that's why we have written. So when we will stop? We will stop alpha plus 2m. See here, you can guess it. Like when it is 4, we have stopped at alpha plus 3. That is, when it is 2m, we are stopping at 2m minus 1. And here we are stopping at 2m minus 2. That is, if minus is minus will become plus. So similarly, we can calculate this one also. So if we put these values, so see, notice that y is c0 plus c1x plus c2x c2x square dot dot dot. So if we collect all the even term, that is c0 plus c2x square plus c4x to the 4 dot dot dot, and plus the odd terms c1x plus c3 x cube plus dot dot dot, because all the even terms we have expressed in terms of c0, and in the odd terms we have expressed in terms of c1. So if we put this and take the common c0, so it will be c0 into y1 and c1 into y2, where y1, the even terms will be there, in y2 odd terms will be there. Obviously summation will be there. So y1 will be, as we have taken common c0, so it will be 1 plus x into this term, and here it will be x plus this term. So this is the solution of Legendre equation, general solution of this Legendre equation. If we take c0 equal to 0 and c1 equal to 1, then y2 is our solution. If we put c0 equal to y1 and c1 equal to 0, then y1 is also solution. So y1 and y2, these are particular solution of this Legendre equation. So one thing you observe that, see, since this m are m equal to 1 to infinity, these are natural number. But if we allow this alpha to be natural number, so what will happen? We are, see, so we are subtracting this. So if it is 2m minus 2, or even any, because here see, alpha is there, alpha minus 2 is there, alpha minus 4 is there, dot dot also there. So if we take alpha as natural number, and alpha, when alpha is even, so this term will become 0 after a few terms, because if alpha is 4, then up to alpha into alpha minus 2 will be there, and then the term will be alpha minus 4, that will be 0. So this series will terminate. This will be finite series. So finite series, that means that will be a polynomial. If alpha is a natural number and even, because we are subtracting alpha minus 2m plus 1. So if alpha is itself alpha equal to 2m minus 1, then this will vanish 0, will be vanished, and then later on term also be 0, because everywhere this term will be there. So if we allow alpha, anyway, if we assume that alpha is natural number, then either this, that is when alpha is even, then this term will get vanished, and alpha is odd, this term will get, this series will get terminated. That is, If alpha is even, this is a polynomial, and alpha is odd, and this is a polynomial. So see, y1, y2 are solution of this Legendre equation. So if we take alpha instead of the real number, if we take that is natural number, so that is the equation will become 1 minus x square y double dash minus 2x plus y n into n plus y. Then we will get 1 at polynomial solution, either y1 or y2. So these solution or these polynomials are called Legendre Polynomial with an extra condition. It has to satisfy Pn1 equal to 1. That is, we have to, that is y1 should be, y1 or y2 should be 1. So here we have seen the Legendre Polynomial, first few Legendre Polynomial. So as I already mentioned, that if alpha equal to 2m kind of thing, that is even, then y1 will be a polynomial. If alpha is odd, natural number, then the second polynomial, that is y2, is a polynomial. So if alpha is 0, then y1 will be 1, because the rest of them series will be 0. And y1 equal to, now alpha equal to 2, that is, these are natural number, even natural number, then y1 will be terminating. So 1 minus 3x square. Y1 alpha equal to 4, then y equal to this. You can put it there. So we have seen few odd for odd alpha also. Alpha equal to 1, this is y2 equal to x, and alpha equal to 3, y2 equal to this. But these are not called Legendre Polynomial. These are actually a solution. We have also known that if the differential equation is linear, then if y1 is a solution, some constant multiple of that is also a solution. So here we have given a definition. The definition I have given, I don't know. No, definition is this: Legendre polynomial. The polynomial solution of degree n of the equation 3, that is this one, and satisfying Pn1 equal to 1 is called Legendre Polynomial. That is, these solution, these are solution of that equation for CF, but these conditions are not satisfied. So these are not Legendre Polynomial. So what we have to do? We have to just make it 1. So how do we make it 1? So we first calculate these polynomial value at 1, and then we divide with that value. So here y1 equal to 1. So y1 is also 1. So first polynomial will be 1 only. So here y1 equal to 1 minus 3, that is minus 2. So if we divide it by minus 2, then that will be polynomial of degree what? Alpha equal to 2. Because alpha, these are the polynomials of degree alpha. Because see here, x to the power 2m. So this coefficient will be x of x to the power 2m. So when alpha is 2m, then this is also 2m. So that polynomial, if it is a polynomial, see here you will see better. So when alpha is 0, then y1 is 0 degree polynomial. Alpha is 2, this y1 is 2nd degree polynomial. Alpha is 4, this is 4th degree polynomial. Alpha is 1, then this is 1 degree polynomial. Similarly. So since y1 is equal to 1, and that is a solution of that equation, so only thing that we have to assure the value is 1 at 1. So y1 is equal to 1, so we have to divide by 1. So p1 equal pn x will be 1. So p2x, that is Legendre Polynomial of degree 2, will be this divided by minus 2. So it will be, I will show it. So we have, that's why we have calculated y1, so that we can divide by that value and we will get the polynomial of that degree. So similarly for this also, y21 equal to 1, y21 equal to minus 2 by 3, y2 equal to this. So the first few polynomial will be p naught x equal to 1, this is coming from this y1, and p1 x equal to 1, that is of degree 1, we have divided because their function value is 1 at 1, so that is similar. So here y1 equal to minus 2, so we have divided by that one, so that's why the sign gets changed, 3x square minus 1. So for p3 we have to divide by minus 2 by 3, so it is half of 5x square minus 3x. p4x equal to this and p4 equal to this. So I have uploaded this in the web, so you go and read it. So thank you for your attention.